So, binary search is a method to find out the target sums. Okay, in the question they have given an array of integer nums which is sorted in ascending order. An integer target is also given to us, and write a function to find that target in the nums. If target exists, then return the index. Okay, we have to return the index, not the target, because they have given the target, so we have to return its index, and if we don't get the target we have to return -1. So usually the main point over here in the question is sorting. Okay, first thing is first, that whenever there is a sorting we have to use binary search. Why? I'll explain you that. Because what's that, just why is it coming in this way? Oh my god, I think this was of earlier sum, so I'm sorry for that. I don't know why it is coming. Anyways, let's take a whiteboard. I don't want to use it anymore here. Let's take a whiteboard. Okay, just let me explain you what is binary search in a fast way. 2 4 6 7 8 10 11. Okay, target is 10. Okay, take this target as 10. I'm putting an indexing as 0 1 2 3 4 5 6. Okay, now over here if you see all the numbers over here, not the indexing. Okay, I'm talking about these numbers are in the ascending order. Of course indexing is also ascending, I'm not saying that, but concentrating on the array or the input array, it is in an ascending order. So we usually, to find any target we have to iterate it, right? We have to iterate it and find where is 10. So we have to start our iteration from 2 4 6 7 8, and then we get 10. But that can be fine if the data set or the input array is small. If there are millions of the number and we have to find the millionth number, then it was going to be difficult, and the time complexity wise it is going to be O of n squared. That's the reason we are using this binary search. And since binary search is always sorted and we know our array is sorted, so let's go ahead and work with binary search, which is a recursive way. Now, what is recursive way? This is an indexing. Okay, don't get confused with this as an array. This is an index. So we have to find the middle number of this. So I'm pointing this as a left side, this as a right side. Now what is middle? Middle is left plus right divide by 2. Okay, so over here left is 0, right? The index I'm talking about, index, concentrate on index. 0 plus 6 divide by 2 is 3. Okay, so we are over here, that means our middle is at this side. Now we have to compare the target versus middle. So the target is 10 and middle is 7, right? So 7 is less than 10, right? What is it? 7 is less than 10. So whenever the target, or whenever the target is greater than whatever middle is, suppose that means target is greater than the middle value, right? That means we have to find the that means we have to find our uh, concentrate our focus on the right side, because target is greater than the middle value. If target is lesser than the middle value, then we would have done uh, the left side. But since target is greater than the middle value, we have to focus our area at the right side and get the value. Again here we'll same 4 plus 6 we will be doing. Here again we have to recursively call that binary method. So when we focus this area, our left pointer will be over here at the fourth index, and right pointer will be at the here at sixth index. 4 plus 6 is 10. 10 divided by 2 is 5, and we get the target. Do you see that? We get the target at the fifth index. So target is equal to target. That means break, because we found our target and we return that index, that it is present at fifth index. So binary search helps to find, but we have to use this binary search recursively. Like suppose you find middle over here, then compare the middle versus target. If target is greater, search at the right side. If target is lesser, search at the left side. right? That is what is the formula. And yeah, and time complexity wise, it takes log of n, because we are every time we are dividing that array and finding out the middle. So time complexity wise, it is O of n. And since we are using O of log n, sorry, O of log n, because we are dividing that entire array and searching the middle, comparing the middle with the target. And that's the reason we have log of n. And space wise also it is log of n, because we are using recursive method. Because in the recursive method, we are again calling this binary search over right portion. Again, if we don't find over here, then again we have to call the binary search towards left portion. So this way we are going to find out, and that's why the space complexity is also log of n for recursive operation. I'm showing you the recursive way. Iterative way I'll let you know later. So let's code this. Actually, I've done the coding. Just let wanted to show you that. Or so basically here I'm taking the array and the target, and then I am going to return what? I'm going to return the index. So how I'm going to return? With the help of this function array. This is the left. This is the right, because left I'm giving it as 0 and right I'm giving it as array dot length minus 1, and then the target. Okay, writing that function over here. So I have written left, let me write in this way, and this to be right. Okay. Then if right is less than left, written minus 1. That means this is not sorted. If this is not sorted, just written minus 1, right? And if it is sorted, then what we have to do? We have to perform, we have to find out the middle value, which I showed you in the diagram, and then compare. If middle is equal to target, then return that middle index and we are good to go. If not, if target is greater than middle, then what we have to do? And if it's less, then what we have to do? Simple. And we are calling this binary method again and again. If it is greater than middle, we have to search in right? We have to search in right. So for that, middle plus 1 is our, from middle plus 1. So this becomes our left till right. We have to find out. And if it is less than the target, then middle minus 1. Before middle, the pointer will be before middle to find our target if it is less than the target. And time complexity wise, O of log n. And space is also O of log n. Thank you.